Hey class, I know many of you are pretty busy with your robots and a few of you have been getting stuck on problem 44 from the homework, so I thought I would go ahead and give you guys a video on this one. So there's two parts to this problem. One, part A, you have a chunk of wood that's sitting in the water with a chunk of lead on top of it, and we're asked to figure out what this mass of lead is if, in this case, 90% of the wood, 90% of the wood, we'll call this about 90% here, is submerged within the water. And then there's a second part, part B, where the situation is really flipped. So you now have your chunk of wood that's still 90% submerged in the water, but now your hunk of lead is attached to the bottom, and we're asked, what is this mass now? And I challenge you guys to think about which one will be larger before you even try to solve. Okay? And then, so pause the video, think about it, make your guess, and then we can try it together. So, first of all, before we get started, in both these situations, we need to keep in mind that density is equal to mass divided by volume, or solving you can find that volume is equal to mass divided by density. There'll be times we need to use both of those relationships. Alright, so for this thing to be in equilibrium, that means that its net force has to be equal to 0. So if it's floating there on the water, that means that the upward buoyancy force is going to be equal to the total weight force of your object, right? Net force equals 0, buoyancy force is up, total weight is down. So what is density force, or buoyancy force equal to? Okay, give you a hint, it has to do with density. So the buoyancy force is equal to the weight of the water being displaced. So the weight of the water being displaced is its density multiplied by its volume. That's really just mass. Again, from here you can see mass equals density multiplied by volume. Alright, so density times volume multiplied by gravity, and this is for the water, keep in mind, is going to be equal to the total mass of our system, which is the mass of the wood plus the mass of the lead added together, times g, gravity. So we can see we got g on both sides, those will cancel out. That's nice, okay, cool. We're given the mass of the wood in the problem statement here, and so the question then is, how can we find the mass of the lead? Well, we can see from this equation, it's just going to be the mass of the water displaced here minus the mass of the wood. But what is the mass of the water displaced? The density of water you can look up. It should be basically 1,000 kilograms per meter cubed. So then we know the density of the water. The volume of the water, as we can see in our picture here, is this volume here, which is 90% or 90.1% in this case of the volume of the wood. So we're going to have 0.901 multiplied by the volume of the wood that's in the water. But volume, since we're not given the volume of the wood, we can see that volume, though, is just equal to mass divided by density. So it's 90% of the mass of the wood divided by the density of the wood. And that, again, is going to be equal to the mass of the wood plus the mass of the lead. So with that in mind, you should be able to determine the solution to the first part of the problem, find the mass of the lead pretty straightforward. So now for part B, we have this situation here. Again, this beginning is the same, right? Buoyancy force minus the total weight is going to be equal to 0, right? And again, it's going to lead to the same equation we had here, which tells us, maybe I'll make a line here, which tells us the density of the water being displaced multiplied by the volume of the water being displaced is going to be equal to the total mass, which is the mass of the wood plus the mass of the lead times G, but I'll just cancel out the G's straight away. So it looks like it's going to be about the same. Just a clarification in case I was unclear here with my subscripts, this W here is for the wood, these here are for the water. Too many things that start with W. Alright, so I'm going to scroll up a little bit here because I'm going to need more space. So I'm going to continue from here and head down here. Alright, so we got the density of water. Now what is the volume being displaced? Well, what that's going to be is that's the volume of the wood that's under the water, which is the 90%, right? Plus, though, now we have the volume of the lead that's also under the water, and that's still going to be equal to the mass of the wood plus the mass of the lead. So what are our two densities? Well, our density of the wood is the same, so mass of the water times the density of the wood, which is still 0.901, multiplied by the mass of the wood divided by the density of wood, plus now we have the volume of the lead, which we're not given, but we do know that it's going to be equal to, once again, the mass of the lead divided by the density of lead, and that will be equal to the mass of the wood plus the mass of the lead. And so now we have a nice, pretty equation strictly from the concept of buoyancy force to determine what the mass of the lead is. We just have to combine our like variables in order to solve. Alright, so we look up here and we can just verify, yes, we are given the things that we need, right? We have here the density of the wood, we have here the density of lead, and with those two bits of information we should be able to solve our equation for the mass of the lead. So I hope this helps you guys. Make sure to get some rest and enjoy your robots.